about 1 Introduction to Complex Numbers. It says use the imaginary number I to rewrite the expression below as a complex number and then simplify all radicals. So let's take a look at this first example here. So we've got the square root of -1, and by definition that is just I. Now we know the square root of 1 is 1, and the negative under there is what makes it imaginary. So if we take the square root of 1, we would get 1. And then the square root of the negative there makes it I. Now we don't really need to write the 1 with it. We can just call that I. 1 times I is just the same thing as I. So if we submit that, they're happy. Use the imaginary number again to simplify this radical. Now in this one, we notice something different. We've got a negative out front, so our answer is going to be negative. So go ahead and put a negative in there. And then the square root of 4 is 2. But that negative under the radical makes it imaginary. So our solution here should look like negative square root of 2i. For this next one, we've got the square root of -36. Square root of 36 is just 6. And again, the negative under the radical makes it imaginary. So that would be 6i. In this one, we have something a little bit different. We don't have a square root of 3. Square root of 3 is just the square root of 3. We can't simplify that any. But what we can do is deal with the negative under the square root. So we've learned our whole lives that we can't take the square root of a negative number, but we can make that number imaginary. So here we could call that negative square root of 3. And then we could make that imaginary, put the I not under the square root. You could also rewrite that as negative I square root of 3. This next one's going to work very similarly. We'd have a negative out in front. We've got the square root of 19, and then we pull out the I. This one is going to be a little bit different because we've got a complex number here and not just an imaginary number. So I'm going to write this as -10 minus, we know that the square root of 9 is 3, so that would be 3i. This one's going to work very similarly to the last one. We can't combine 19 and the square root of -15, but what we can do is simplify the square root of -15 to be the square root of 15 positive, and then have an I multiplied with that. Here we've got 17 minus, we've got the square root of -16, which would be 4i. Square root of 16 is 4. The negative makes it imaginary. If we keep working here, we get a similar question, and we'll work this into a smart score of about 80. This would be square root of, it'd be 19 plus the square root of 5, and then the I goes outside of the square root. Takes care of that negative. All right. So here we have to do a little bit of simplifying of radicals. So we've done that unit, so that's nice. We know that 20 would break down to 4 times 5. The square root of 4 is 2, so we can pull a 2 out. And then underneath we would still have the 5, and that negative makes it imaginary. With 8, we know that 8 would be 4 times 2. So we could take the square root of 4, which is 2. And then we have square root of 2. So square root of 8 would simplify to 2 square root of 2. And that negative underneath means it needs to be imaginary. We'll do a couple more here together. 50 is 25 times 2. Square root of 25 is 5. So we'd have -5 out front. Square root of 2. And again, that negative underneath makes it imaginary. Square root of 98. So I'm going to use a calculator here and divide that by 2, and we get that that's 49. So if you have a bigger number like this, it might be good to check it in a calculator. So we know that 49 though is a perfect square. The square root of 49 is 7. So you can do 7, and then under the radical would be just 2 left under there, and then that negative makes it imaginary. So 7 square root of 2 I. We'll do one last problem. So 68, if I divide 68 by 2, I get 34. 34 is not a perfect square, so I'm going to divide it by 2 again, and I'm going to get 17. Now 17 is prime, but I've taken out, the prime factorization would be 2 times 2 times 17. So if you've got a group of 2's, we could take a 2 out, so we'd have a negative 2 out front. We'd have the square root. 17 did not have a pair, so it stays underneath, and it is imaginary. I hope this was helpful for IXL section I.1 for Algebra 2, Introduction to Complex Numbers. Thanks for watching Old School Math. If you have any questions, please leave them below.